For thousands of years, humans walked, they carried, they dragged. Every journey was exhausting, every load was heavy, until one day something rolled. And just like that, it didn't just move objects, it moved civilization. Welcome to Innoing Science. Today, this is the story of wheels, from wood to speed to the modern world. Our story begins around 3500 BCE in Mesopotamia and the Indus Valley. First wheels were simple, solid wooden discs cut from heavy slabs. Heavy, yes. Slow, definitely. Revolutionary, absolutely. Because for the first time, humans developed a life-changing truth. Rolling is easier than sliding. When you slide a heavy box, microscopic rough points on the surfaces lock together. Keep moving, you must constantly break those tiny bonds, and that takes serious effort. But when something rolls, there's almost no scrapping. The wheel simply moves forward, smoothly, efficiently. And just like that, transportation was born. But, and there is always a but, the first wheel had a problem. Early wheels had a weakness. The wheel rotated on a wooden axle, wood rubbing against wood, which meant friction, heat, and very fast wear. So humans made their first upgrade. They placed a sleeve of soft wood or bronze between the axle and the hub and added grease or animal fat for lubrication. Was it a modern bearing? Not even close. But it was a step towards the one, because even at the ancient times, engineers were fighting against friction. Solid wheels worked, but they had one major flaw. They were heavy. So around 2000 BCE, chariots introduced one of the greatest upgrades ever, the spoked wheel. Suddenly, wheels became lighter, and lighter means faster. Here's the science behind the glow up. A wheel's resistance to spinning is called moment of inertia, and it depends not just on how much mass you have, but where that mass is sitting. Mass far from the center resists rotation much more. So spoked wheels did something brilliant. They removed heavy wood from the rim, kept the strength and reduced inertia. Less inertia, quicker acceleration. That's why bicycles even today still use spokes. Some designs just don't go out of time. Spoked wheels were fast but fragile. Wood cracked, wore out, lost shape under stress. So humans added something game-changing, a metal ring around the wooden wheel. That metal ring protected the wheel, kept it perfectly circular, and compressed the whole structure tightly. One simple metal band and the wheel life increased dramatically. Sometimes the smallest upgrades make the biggest difference. For centuries, wood ruled transportation. But then came the Industrial Revolution, and suddenly everything got heavier, faster, more demanding. Wood started showing its limit. It absorbed moisture, it warped, it failed under extreme loads, and metal became the future. Then railways entered, and rail transport pushed wheels harder than ever before. Early railway wheels were cast iron, strong in compression but dangerously brittle. Engineers improved them. First came wrought iron rims. Then by early 90s, steel took over completely. Stronger, tougher, safer. Now here's one of the most brilliant design of history. Railway wheels are slightly conical. Why? Because both wheels are fixed to one axle. They rotate together. But on a curve, the outer rail path is longer, the inner path is shorter. A cylindrical wheel would slip, so it designed a slightly conical. When the wheel set shifts slightly, the inner wheel rides on a smaller radius. The outer wheel rides on a larger radius. So the outer wheel naturally travels further. No sensors, no electronics, just pure geometry was doing this thing. This is working reliably for more than 200 years. Now here's the hidden breakthrough that made modern speed possible. Sleeves helped reduce wear, but sliding friction still wasted energy. So engineers introduced rolling element bearings. Instead of sliding, tiny balls carried the load while rolling, which meant less friction, less heat, far greater efficiency. By early 90s, wheel bearings became essential for every vehicle hub. Without bearings, modern transportation simply wouldn't exist. In 1885, Carl Benz built the first practical motor car. It used solid rubber tires around its wheel. Because metal wheels on road creates zero grip, rubber introduced something critical: traction. Traction simply means grip. Without grip, a wheel slips instead of moving, skids instead of braking, slides instead of turning. Rubber deforms slightly, creating a larger contact patch and locking into tiny road irregularities. That grip made automobiles controllable. But solid rubbers had a problem. They were hard. Every bump hit the vehicle directly. Not exactly a smooth ride. Then in 1888, John Dunlop introduced the pneumatic tire, an air-filled tube inside the tire. And air turned out nature's perfect shock absorber. Pneumatic tires improved comfort, traction, speed. Because along with speed, comfort became an important criteria. The modern driving era began. Early cars mostly used wire-spoked wheels, light, elegant, first. But braking exposed their weakness. When brakes are applied, the hub tries to stop instantly, while the rim and the tire still want to move forward because of inertia. That creates twisting force, torsion inside the wheel. Wire spokes could flex under this stress. Pressed steel disc wheels, however, were much stiffer. The solid disc spread braking torque across the entire wheel, resulted stronger, safer, cheaper wheel, perfect for mass production. And just like that, disc wheels took over. Cars were faster now, but roads still rough. And speed without comfort is basically a torture. So engineers introduced suspension. Suspension springs act like energy buffers between the wheel and the car body. When a car hits a bump, the wheel moves up, the spring compresses and absorbs the impact energy. Then the spring expands smoothly, releasing that energy gradually, and wheels move, but the car body stays relatively calm. Is the problem solved? Not yet, because springs alone caused bouncing. So engineers added shock absorbers. Shock absorbers act as dampers, turning oscillation energy into heat and stopping endless bouncing. Spring absorbs, shock absorber controls. Finally, comfort was engineered. By 1920s, another safety upgradation appeared: tire tread grooves. On wet roads, water forms a thin film between tire and ground. If the tire can't push that water away, it starts to float and grip disappears. Grooves act like drainage channels, squeezing water sideways and backward, keeping rubber in contact with the road, which improves wet grip, braking, cornering stability. Small lines, big safety. Tube tires had one dangerous flaw. A puncture could cause instant collapse because the air lived inside a thin inner tube, basically like a balloon. One nail puncture and boom. Tubeless tires changed the game. No separate tube, the tire itself holds the air using an airtight inner liner and bead seal. And when a nail punctures the tread, it often stays stuck, acting like a plug. So air leaks slowly, giving the driver precious time to stop safely. By the mid-1950s, tubeless tires became the global standard. Tires kept evolving. Early tires was bias ply with cords laid diagonally. They overheated, they wore quickly. Then in 1946, Michelin introduced the radial tire. Radial tires had cords running straight outward. with steel belts under the tread, resulted better grip, less heat and longer life. Radial tires have now become the modern standard. Steel wheels ruled for decades, but manufacturers wanted lighter options. In 1960s, aluminum alloy wheels entered, about 40 to 50% lighter than steel, which improved handling, brake cooling, fuel economy. Aluminum alloys quickly became new favorite. And today the wheel is still revolving. Some supercars now use carbon fiber wheels, which is ultra light, ultra strong and ultra expensive, because the story of wheels is still rolling forward. From wooden slabs to spokes to steel to bearings to rubber to air to suspension to grooves to radial tires to carbon fiber, the wheel isn't just a circle. It's the story of civilization moving forward, one revolution at a time. If you enjoyed this video, please like, comment and share my channel. See you in my next video. Bye bye.